In this tutorial, I'm going to show you how to write a more complex Arduino program. Once your students have tried running the programs that are available here, and once they've tried altering them and loading them, and they're comfortable with that, it's time to give them a challenge. How about this challenge? Write a program to control the remote laboratory such that the LED blinks on and off for a second 5 times. Then the DC motor runs forward for 3 seconds and backward for 3 seconds with a 1 second delay in between. Then the stepper motor makes 75 steps forward and then 75 steps backward at double step type and with a delay of 1 second between movements. And the above action should be put into a loop to run infinitely. So, shall we have a go at writing that program? You'll see the program has 3 main parts, and actually a lot of the code is already available in the programs that we've already seen. It just needs changing a little and putting together. So I suggest a good way of tackling this problem is to write it in steps and save each step as a piece of code and then bring them all together. So the first task is to write some code that makes the LED blink on and off for a second 5 times. So to do that, let's get the blinking LED code. Here it is. Well, at the moment, the code that makes the light blink on and off is in a loop, in an infinite loop, and it goes around and round. Well, we only want that to happen 5 times, so we'll put a for loop in. And that should do the trick. Actually, as it stands at the moment, it would carry on blinking on and off forever because it's still in the infinite loop. But when we put it together with the other parts of the program, we'll make it such that this is a sequence. This loop of blinking on and off is a sequence first, and then we go into the sequence of the DC motor, and then we go into the sequence of the stepper motor. So let's store this program. I'll call it LED 5 times. And I'll keep the code private. Okay, so we've got our for loop. And now what else did we have to do? The next thing is the DC motor must run forward for 3 seconds and backwards for 3 seconds with a 1 second delay in between. So let's get the code for the DC motor. I might simplify this code a little bit and take out some of the parts that we don't really need. We don't have to have the serial text stream, so I'll take that part out. So we've declared our DC motor as motor and it's on port 1. We've got the speed set to 200 and we set it to idle. So that part's fine. And then we just want it to run forward for 3 seconds and then backwards for 3 seconds. So we don't need the for loops here that's actually increasing the speed. And similarly, we don't need the for loop that's decreasing the speed. But we do want to have, once we've set the motor to run forward, before we give the next command, we do want to have a delay for 3 seconds. So we put delay 3000 milliseconds. and then we can ask the motor to run backwards. And we've got that command there, motor run backward. And then we need another delay for 3000 milliseconds. And let's just see what exactly we needed to do. Forward for 3 seconds and backwards for 3 seconds with a 1 second delay in between. So we've got forward for 3 seconds, backwards for 3 seconds, and for the 1 second delay we can put the motor to idle, and the command for that is motor run release. And we need a delay of 1 second. So we can put the delay 1000. So we can take that for loop that's left from the previous program out. That was decreasing the speed. And let's see. Yeah, okay, I think that should do. But perhaps after the backward movement it would be good to have a delay of 1 second as well. So I'll put a little bit more code in to do that. So after it's run backwards, we'll set the motor to idle and wait a second. Now we don't need the serial print because I've taken out the serial print stream. I'm not using that integer I, so I can take that out. And we don't need the serial print tick. So that should do for the DC motor part. So I'll save that code. And I'll call it DC motor part. And I'll make it private and save the changes. There's the code. It looks okay. And now for the stepper motor part. So the stepper motor makes 75 steps forward and then 75 steps backward at double step type with a delay of 1 second between movements. So let's get the stepper motor code and see how we can alter that. Again, I'll take the serial stream out. We need to set the speed of the motor. What did we say? Was it single steps? No, double steps. Okay, so, and it was 75 steps. So we don't need the part about the single steps. We don't need the serial stream. We'll have 75 steps forward and 75 steps backward. And a delay of 1 second between movements. So we can put a delay of 1 second between the forward and the backward. And then we can take the other types of steps from the previous program away. And that gives us the basic code that we need. So I'll store that. I'll call it stepper part. Make it private and save the changes. There's the code, I can check. It's okay. Right, so those are the 3 bits of code done. The LED, the DC motor and the stepper. We now need to put it all together. Let's get the LED part back first. LED 5 times. And we've got our loop that allows that to happen. I'll just indent the code to make it a little bit clearer. Because we need to put this code all together, we're not going to be able to do it in the window provided in the interface, so we need to get a notepad document. So I'm going to copy this code into the notepad, and then I'll add more to it. Now, let's get the next piece of code. It was the DC motor part. So again, I need to put this into the notepad. Copy. Paste. Right, well I only want one loop, so let's just grab that part, the part that's in the loop. Cut. And in the notepad document I'll just put the DC code after the for loop for the LED blinking on and off. So now we see the sequence. We've got the LED blinking on and off, and then we have the motor running forward for 3 seconds, a delay of a second, and then running backwards for 3 seconds. So what else do I need? Well, I need to have the library for the motor routines, so we need to put that at the top of our program. In the setup, we need to turn the motor on and put it to idle. So we've already got in our setup that the pin mode 13 is output. But actually, at the moment, we've lost that integer declaration for the LED, so I'll just put that back in. Usually the LED is on pin 13 on the Arduino boards, but it can be on any pin anyway. We declare LED to be integer to be 13 here, and then we say the pin mode for pin 13 is output, and there's going to be an LED connected to that. Then we set the speed of the motor, and we set this motor to idle. And then within our loop we've got the for loop which puts the light on and off, and then we've got some commands that makes the DC motor run forward and then run backward. But we haven't put the stepper motor part in yet. So let's load up the code for the stepper motor that we wrote earlier. Here it is, stepper part loaded up. And now let's see which parts of this that we're going to need. So we've already got the library declared, so we don't need to cut that part out and take it across. We need to declare our stepper motor, so we'll cut that part out and take it across. We need to, let's look down at the stepper motor code. Well, we have to set the motor speed. Motor set speed 10, sets it at 10. Let's copy that and put it into the notepad. and that goes into the setup. And then here's the commands. We're going to ask the motor to step 75 steps forward, then delay for a second, then step 75 steps backward. So if we copy that and take it across, and we put that at the end of the loop. So now we've got three sequences of code. We've got the light going on and off, and then the DC motor going forward and backward, and then the stepper motor going forward and backward. But is this code quite right? Let's have a closer look at it. Now then, there's something wrong here because of the actual declaration of the motors. We've actually only declared one motor, the stepper motor. So we must have forgotten to bring across the declaration of the DC motor. So I'll just put that in. And that's going to go on channel 1 as it was previously. But now what's wrong? We've got the AC stepper called motor, and we've got the AF DC motor called motor. So we're going to have to change the names so we can distinguish between them. So we'll call the DC motor motor 1, and we'll call the stepper motor motor 2. Now then, wherever we refer to those in the code, we have to distinguish them by 1 or 2. So the DC motor's 1 and the stepper's 2. So this here in the second part of the sequence in the loop was the DC motor. So that one is 1. So I'm going to change the name to 1. And the second one was the stepper motor, so that's 2. Okay. So, oh yes, there's the declaration of the DC motor that should have been taken to the top earlier on. So, actually, I'll do that now. Okay then, so we're ready to have a go at this program. Let's just take a little look. There's still some things left down here that we don't need, so I'll take that away. And now we can try running the program. So let's copy it all. And let's put it into our workspace. And now let's try uploading and running it. It didn't upload, and we've got some error messages here in the results section. So it says AF DC motor does not name a type test INO in function void setup. Okay, so it doesn't like the declaration of the DC test motor. So I think maybe it's to do with the actual way that it's written. I think perhaps it should be DC test motor with a capital M there. So let's try uploading that. Test, well, we've got a different error now. So test INO in function void loop. Error. I was not declared in this scope test. Error expected semicolon before the end bracket. So it says I was not declared. Now we used I in our for loop, but actually, yes, we forgot to declare it. So let's declare I at the top. There. Now let's try uploading the program again. We still have a problem, and this is expected semicolon before the bracket. Oh, it looks like we've forgotten a semicolon. One of the oldest problems, one of the commonest errors in programming, and there, right at the end, we didn't put a semicolon after our last command. So now we upload. And this time it looks more promising. The code has been uploaded. And yes, the light is blinking on and off 5 times. And now the DC motor is spinning. Forward, delay. And then backward, delay. And then the stepper motor. Forward, then backwards. So we can see that we have met the challenge of writing a program whereby the LED blinks on and off for 5 times, and then the DC motor runs forward for 3 seconds and backwards for 3 seconds. And then the stepper motor moves forwards and backwards. So you can see that this is quite an interesting challenge for you students, but not too difficult. It's something that they should be able to do. They'll make little mistakes, like I made in the program in here, forgetting to do things like semicolons, forgetting to declare variables sometimes, or perhaps giving the wrong commands for the motors. But eventually they should be able to get the program to work, and it should be a fun challenge for them. So let's just save this code as motor fun. And I hope you and your students have fun with the remote laboratories.